All right, so we're gonna do an algebra review, and so these are kind of, these are problems that are involving more than one variable, and we're gonna try and solve for a particular variable, one of them. And the way we're going to do that is by using substitution. So we're going to kind of include distributive property in these problems. These are good problems. So let's get into it. So it says solve for x if 3x plus y all over 5 equals 16 and y equals 7x. Now, the way we do these problems is that we look at y here, and we take y and we get it in terms of x. What in terms of x means that we see y equals x, and then we see other numbers. So it's just x's and numbers on this right-hand side. So y equals all x's and numbers. So it's already in terms of x. So what we do is we take what y is and we substitute it into one of our equations. So we take what y is, we substitute it, and we see y is 7x right here. So we have 7x plus 3x, and we have all x's and numbers now on this equation, which means we can solve for what x is. It's just one variable, and we can just, for one equation up here now, and we can figure out what x is. All right, so let's, I'm actually going to explain what you shouldn't do when doing these problems, okay? So this is the first step. But one thing that's very common that I see here, and I want you to kind of explain what I'm doing wrong. So right here we have 3x plus y over 5. Y is equal to 7x, and then that's all equal to 16. I multiply both sides by 5, so the 5's over there. And then what happens? What happened there? This is actually a very common mistake in algebra when you're getting used to these problems. What did I do wrong there? I wasn't writing in sentences. I wasn't. What else was I not doing? The main problem with these is that what you're seeing here are incorrect, little errors, kind of thrown in here. Like it's kind of your thoughts, but you're not fully committed to it, as far as you're not deliberate as far as your substitution went here. You took an equation and you kind of combined it in a way that wasn't proper. You didn't fully commit. You weren't fully deliberate. So you want to be very deliberate when you do this. When you substitute, you take what y is and you just substitute that number. You don't write another equal sign. You don't blend it together in that way. That's one thing. What's another thing that I did? One thing that I will say, all this stuff going on here, I didn't utilize my space. It's important to use your space to your advantage. I write in sentences in order to utilize my space fully. And what that does is it allows me to keep track of my thoughts continuously throughout the whole thing, instead of cramming it all into one and not seeing the whole picture. So that's another thing. All right, so let's try and do that again. Let's try and use the space, and let's try and go for it. So we started out good, here I always write so. Let's just write so. Okay. And we had this equation over here. Now, what I'm going to do is I'm going to say, here we have y is equal to 7x. So I'm going to take what y is, and this is just a visualization thing. I'm going to substitute it over here. Now, this is the deliberate part. So we don't write another equal sign. Y is just 7x. So y is 7x. When I substitute what y is, I'm just replacing 7x with y. So instead of y is no longer y, it's 7x. So you got to be deliberate. That's that one error. Got to be fully committed. So I'm going to rewrite this whole equation, and then I'm going to carry down that 16 here. So I have that. I'm on to a new step. I'm on to a new thought. I'm not going to combine these, and write equals 10x. I'm on to a new step, new thought. Important. It's very important to show your work clearly with these. So 3x plus 7x is just 10x up top, divided by 5 is equal to 16. Think baby steps. Don't try and do it all in your head. Okay, so I'm just saying that numerator just simplifies the 10x here. So the baby step is an important step to make, though. Small steps. The next step. 10 divided by 5, that's just 2. So I have 2x equals 16. Keeping track of my thoughts. Every step is small. I'm not writing all over the place. I'm writing in sentences. I'm following it up with everything. And then we have, so x equals 8. Because 2 times 8 is 16. And then we're done there. It's a lot nicer, isn't it? It's a lot better form. Part of algebra is not necessarily, trying to do it all in one step, one movement. It's to get you to use the space. It's a very important concept, and it doesn't go away. You want to use that to your advantage. All right, so that's number 1. All right, let's do number 2. Solve for x if 7 over x is equal to y, and y is also equal to 100 divided by 9. We could just figure what that value is on our calculator, but it's important to deal with fractions. And, we have to use our fractions again to our advantage. We have to get comfortable using our fractions here. Again, what I'm going to do is I'm going to start off by taking whatever y is and substituting it. It's the same process for all of these. We substitute whatever y is. A lot of times what you'll see is that you'll see something like this. You'll have a lot of people just, instead of, will try and blend it all together. When you substitute, you want to be deliberate. You want to say y is no longer y. Y is 100 over 9. I am going to replace that object, that 100 divided by 9, right there. So instead of, combining everything together and worrying about what the y is, when you take that value, that 100 over 9, you are replacing it with y. You are replacing it. Now here we can get x out of the denominator by multiplying both sides by x. But what's another way of doing this? Just cross multiply, right? But what we see here is the scenario where we can just cross multiply and then figure out what x is. So cross multiply is where you do your cross. So it's 7 times 9 is 63. So we're going 7 times 9 is 63. Then 100 times x is 100x. Now we can show certain steps too. We don't have to do everything. You don't have to do, jump to here right away. But it's important to kind of, I would, but personally, but if you're here, what you can do to show the next step, if you're more comfortable sometimes, go from here to here to that step. In other words, whenever we divide by, 100 here, our decimal is here, we're just moving it over 2 because we have 2 zeros. So if we take it the decimal, we move it over 1, 2 spots. So 0.63 must be equal to x. I also wanted to point this out. When I didn't do this for a long time. I would just leave it as 0.63. It's fine like that. I don't know why, but it makes it a little more clear to write the 0.63. It's a little more common to write it like that. I put the 0 in first whenever you get a decimal. All right, so there's that one. Notice how I was writing down the entire way. I was using my space and I was showing my work to, using my space to my advantage. I was showing my work so I can check my work along every step. It's not all in one location. If you're writing all in one location, you need to write in sentences, really force yourself, tell yourself to write that next so, comma. Use your space. And that's what that allows you to do. When you write that so, or you're that transition right there, that forces you to use that space. That's number 2. Three. So we're going to ask to solve for x if 3 times 5x, 3 times the quantity, 5x minus 16 equal to 7x, and y equals 3x. Actually, sorry, y equals 7x minus 10. Maybe just make this 16 a little bit better here. All right. Again, with all these problems, I take what y is, and I substitute it. Wait, there's no y. There's no y. So this right here is, this equation is actually, it's useless. We already have x, our variable x. There's one equation. We can just solve for what x is. We don't even care about that. There's no substitution to be done. We already have one variable and one equation, which means we can solve for what x is. Do the distributive property, 3 times 5x. 3 times 5 is 15, so it's 15x. 3 times 16 is 48, so I'm going to write minus 48. The reason for the minus sign is that symbol right there. You're going 3 times a minus 16, so it's minus there. And then I want to write an equal sign from here. I carry every single bit of information along with. At this point in time, I'm on to here. What I'm going to do for my next step is I'm going to subtract 7x on both sides. When I subtract 7x on both sides, 7x is gone over here. So I subtract 7x on this side, I am left with 8x, because 15x minus 7x is 8x. I'm going to scoot that minus 48 over to the other side. And in doing so, it changes the sign. At this point, it should be kind of clear that x is equal to 6. We divide by 8 on both sides. If you need that step, I actually prefer, writing from here to here. Personally, I do that. I jump from here to here. But if you need that extra step, every now and then, it's good to show. All right, so that's how you do number 3. Let's say we're going to solve for x if x over y is equal to 11 and y plus 7 is equal to x. Here, again, I take what y is, and I'm going to substitute whatever it is. So you want to notice what the problem is here. Substitute. I don't have y alone. I don't have y in terms of x yet. So I can't substitute right away. I can't substitute right away. So this involves a little more work. And let's just, for habit, let's just rewrite the whole thing and again for another step. So we have x over y equals 11, and we're given that y equals, so I'm just going to subtract 7 on both sides, x minus 7. So all I am is I'm getting y in terms of x for my substitution for my next step. That's a step in itself. Now I can do my substitution properly, my replacement of what y really is. Y is now x minus 7. So I replace that object with x minus 7. I don't write it, right over it. I don't erase it. I go on to the next part. So I get x over x minus 7 is equal to 11. Now I need my x minus 7. The x is in the denominator. I need that out. I can't just multiply by x by both sides because I have this whole term stuck in the denominator, this x minus 11. So what I'm going to have to do is I'm going to have to multiply both sides by x minus 7 to get this whole term out. So I get x is equal to, that x right there is right there. And when I multiply both sides by x minus 7, this term is gone on the left-hand side. So x is equal to 11 times x minus 7. It kind of takes this term over here and it swings over and it hits that. So x is equal to 11 times x is just 11x. 11 times 7, don't forget the minus sign, minus 77. Now, for some reason, what I always do, and I don't know what this is as far as the process goes, I always try and keep, the term right next to the x positive. It just makes it a little easier for me. I don't know why. But so I subtract x on both sides. I get 10x. And then I move the 77 over to the other side. That flips the sign. It changes the sign. So I'm subtracting x on both sides. So you're going 11x minus x is 10x. And then I'm taking that minus 77 and I'm scooting it over there. Notice I'm not really writing an arrow there. I'm just doing it in my head. I'm doing it over to the other side. So 77 divided by 10 must be what x is, right? Because I divide both sides by 10. And remember, the decimal just moves over 1 here because I have 1 0. So really, x equals 7.7. So that's how you do that. Erase this. On to the next one. There's only 7 columns here, so I'm going to run on to 5. All right, this is the best one, I think, on this. 7 halves x, 7 divided by 2 times x minus 2y equals 1, and we're given that y is equal to 5/3 x. That's the first step. I take what y is and I substitute it. So I take what y is. I personally just show this step, even on my paper. You know, substituting it. I'm taking that value and I'm replacing it. What's the one thing about technique on our substitution? You can't go wrong with parentheses. So you have 7 halves, 7 divided by 2x minus 2. Parentheses, can't go wrong with parentheses around that y. What we're substituting. Y is no longer y, it's 5/3 times x is equal to 1. Period. End of thought. We substituted. Now let's go on to the next step. 7 halves x. 2 times 5 is 10 up top. Keep the 3 down below. There's x is equal to 1. Done with that. All right, now we have to find a common denominator. A lot of times you'll see certain people. Did you know when you do this, and so this is in red, so when you do something like this, when you're saying 7x plus 3x is 10x, what you're really doing is you're saying that 7x plus 3x is equal to 7 plus 3 times x. You're factoring out the x when you're doing that. And I just want to, and then you know 7 plus 3 is 10, but every time you're really simplifying in that way, you're factoring out an x like that. And just like that over there, I can do the same thing. There. And now it's a fraction problem, right? So right here, how do I find a common denominator between those two? If I have 7 divided by 2, and I have 3, how do I find a common denominator there? I just take those and I multiply them together. Whatever's in the denominator, I'm multiplying them together. There's a 6, because I'm going 2 times 3. That's my common denominator here. So I multiplied this by 3. I have to multiply the numerator by 3 as well. I multiplied this by 2. I have to multiply the numerator by 2 as well. Then I have my minus sign right there. And so end of thought, on to the next one. Now, what I see, one thing I do notice happens a fair amount is that once you find your common denominator, you don't just reduce it right away. Like you found your common denominator for a reason, so you got to keep your 6 down there. You're combining these values now. So you're going 21 minus 20 is 1. It's just 1. So 21 minus 20 is 1. So I'm going to write 1. And that times x is equal to just 1. I multiply 6 on both sides. When I multiply 6 on both sides, 6 is gone in the denominator. I'm just left with 1x now, right? 1x is just x, and 1 times 6 is 6. So x is 6. Now number 5. Solve for x if, sorry about that. X times x plus 1 is equal to x minus 3, x minus 12 plus k, where k is equal to -4. All right, that's what I'm talking about. That's a good one too. So we're trying to figure out what x is, so I'm just going to take what k is, substitute it. Just taking what that is and substituting it. Now, do I just write over there, or do I go on to the next thought? I go on to my next thought. So I'm going to write, like I don't just write 4, -4 right there. I'm going on to my next thought. I'm writing out the whole thing. I'm using the space. And whenever we substitute, remember our parentheses. In other words, we have a plus and a minus. I could just write -4 right here. No harm in doing that. All right, so I'm just taking what k is and I'm writing that number there. Now I have everything just in terms of x. There's no k here anymore. Now I can figure out what x is. Let's just look at our left-hand side. Think baby steps on these problems. This really isn't a bad problem. This is a cool problem. Think baby steps. There's small steps that lead to a larger process. They're going x times x. That's x squared. X times 1. That's just x. X times x is x squared. You're going minus 3 times x, so it's minus 3x. Minus 12x is a minus 15x. So I got minus 15x. And then you go minus 3 times a minus 12. So that's a positive, because 2 negatives, when you multiply them together, that's going to give you a positive. 36 minus 4. Now, at this point, what I'm going to do is I'm going to say 36 minus 4. Instead of rewriting the whole thing, let's just do that. 36 minus 4, what is that? That's 29. So I'm just going to write 29 right there. Wait a second, 36 minus 4. What am I thinking? 36 minus 4. What is that value? That's 32. Sorry about that. 32. 32 right there. That's why it's important to show your step for the next one, so that way you could catch that here. So it's 32 right there. All right. Now, the x squareds cancel out. I subtract x squared on both sides. These things are gone. So what I'm just left with x equals minus 15x plus 32. Just, again, I'm not trying to combine too much. I'm doing small steps. I add 15x on both sides. I get 16x is equal to 32. And therefore, I divide both sides by 16. 32 divided by 16, x is 2. All right, so that's number 6. Number 7. All right. And then this is the last one. Solve for x if x minus 1 divided by 100 is equal to c, and c is equal to 9.1742. Again, I'm stuck with that C right here, right? I'm stuck with that C. So what I'm going to do is I'm going to rewrite, instead of C, I'm going to just write x minus 1 over 100 is equal to 9.1742. Now, at this point, I'm going to multiply 100 on both sides. So when I multiply 100 on both sides, I get x minus 1 is equal to 9.1742 times 100. Imagine that 100 swinging over and it's hitting that. I'm canceling out the 100 on this side, and now it's popping up over there when I multiply it on the other side. Now, you see the 100 here, so there are 2 zeros. So I'm just going to take this decimal point, I'm going to move it over 1, 2. 2 to the right. It's getting bigger because I'm multiplying it by 100. I'm moving it over to the right. So I get x minus 1, and then we have 917 point, because I'm multiplying it by 100.42. Now I just add 1 on both sides, so x equals, when I add 1 on this side over here, it just affects the 7, because it's the units digit, so that's now 918.42. I'm just adding 1 on both sides. Now, I didn't write in sentences. I think it's important that, you see one where it isn't written in sentences. What did I do here, though, instead? I wrote everything straight down. Did I use my space? Yes, I did. So instead of, and sentences are the ideal form, but I'm trying to get everyone in the habit of using their space. So that's the trick to doing these problems, is to use your space and, think every step is a small step. If you understand that and you're all in on these problems, I'm sure you can do it. Okay? I hope this video helped.